Let me welcome you to the fourth lecture of SIAM NPTEL online certification course network analysis for mining and mineral engineering. So, in this lecture 4 we will discuss introduction to activity on node diagram and comparison with arrow diagram. In last class we have discussed how to construct a project graph in using the arrows. That means, how a network which is basically comprising a number of activities or job can be framed or can be shown in form of a network using the arrow diagram, where arrow diagram means where the jobs are denoted on the arrow by its name and duration. So, this is the way we represent a job or activity in terms of arrow, and in the last lecture we have seen, while we have tried to use this arrow for framing a network which basically gives the complete activities or schedule, but we faced a number of problems where the complex relationships of the precedence and succedence of the jobs are there and restrict the user to construct the network very easily using this arrow diagram. So, the user is forced to use a number of dummy activities to complete the network, which is nothing but the dotted line represent as the dotted arrows in the network, and essentially those are of 0 length, which is having 0 length and 0 costing. So, basically the 0 duration 0 costing dummy network pseudo jobs are added to show the precedence of the jobs for completing the network, which are not actually existing. So, basically it has been found it is very difficult for a new user to foresee where the dummy activities should be added, where not to be, but dependencies are there. So, that is why it is for the new user it is very difficult to find out the position where the dummy activities can be added to define the complete network. So, that is why there must be some different types of system where it can be easily the network may be framed, even if a new person can do it very easily. So, basically in this lecture we are trying to address this, where we will discuss the activity on node diagram, which is basically avoiding this, what are the steps of this activity on node diagram. Then we will compare activity on node diagram with activity on arrow diagram, that is the arrow diagram, and we will understand some examples of mining and construction. With some example we will understand the constructional difference of activity on arrow and activity of node diagram. So, this lecture is also another very simple lecture. Say activity on node diagram is constructed so that the jobs are mentioned in the node and the immediate predecessors relationship between two jobs is shown by an arrow connecting two nodes. That means, while the arrow diagram we are mentioning the job is A of length t, which is started from node 1 to 2. In this case, we are representing a circle which is the node, where we mention the job and its duration within the node. That means, if A is preceded by x, then the arrow x arrow is coming into the node 1, which gives the idea that x must be completed prior to start of A, and node 2, the point where the arrow is being ended, after that if the job B is there, that means B is the successors of the A. But in this case, as it is represented in the node, that means the preceded job again, which is also mentioned in the node, has to be shown in this way, so that the precedence and successor of that particular job can be mentioned. So, the nodes A, B, C are basically representing the activity of the job connected to that, and arrows are basically shows the predecessors and the successors of that job of that particular job. So, basically this is a different kind of diagram where the activities are placed in the node, and that is why it is easier for anyone to draw this diagram. That means, a person can write all the jobs and just name of the jobs, circle them, then the jobs are mentioned in the network. Now, to show the predecessors and precedence and the succedence, just the arrow has to be placed. So, like this way arrow can be made. So, that means it is very easy for a person to understand that these are the jobs required for the as the predecessors of that job, and these are the jobs that are the successor of that particular job. So, C and E are the predecessors of A, B and D are the predecessors of successors of A. But this is actually a wrong diagram, where you will find out some problem related to the cyclic mode of the network, but the giving the precedence and succedence of a job is very easy while you are presenting the job on the network. Only by giving the arrow connecting to that network or ending at that network shows the precedence of that job, and the succedence is shown, which are the arrows coming out from that node is showing the succedence. So, basically the construction of the network is very important or very easy in this activity on node diagram. Now, let us see how we can construct a activity on node diagram. So, this is activity on arrow diagram, this is activity on node diagram. You can see this is a little bit lengthier one, this is a smaller one, and this representing the two successive activities A, B using the activity on arrow and activity on node diagram. And if you see, it is found in the previous arrow diagram that addition of dummy jobs is a cumbersome procedure, because calculation to perform critical path or path scheduling make use of all jobs, and hence are lengthened the calculation part in the system. So, that means the moment we are using a dummy job, we are lengthening the calculation process and creating the problem. So, that without that dummy job, it is very easy for a person to calculate it, or the computer calculation time may be reduced as the number of jobs are getting reduced. So, using an activity on node diagram, we can eliminate the dummy job, and you can see with this example where you can see activity on arrow diagram, this dummy job is required for this example which we have already discussed in the previous class. So, this dummy activity is required so that we can construct this network in the activity on node diagram, activity on arrow diagram. But if you try to present it in a activity on node diagram, then you can easily find out there must be a starting node. From that, the first two jobs which are A and A dot, let me clear it once. A dot, these two job are the starting job which does not need any predecessors. Then we are having job B which is having both A and A dot as the predecessors. We are having job C which has only A as a predecessor. We are having job D which only C is the predecessors, and we are having job E which both B and D are the predecessors. Then we have to end the network by providing a predecessors at this point. So, basically what we are doing, we are forming the precedence and succedence while we are placing the jobs on the node, and only the arrows are given for showing the precedence and succedence, and that is why we do not need a dummy activities which were required at this position. So, this is very easy to construct the network in activity on node diagram, where we do not need to use the dummy jobs. Now, let us see the steps for constructing the A1 diagram. So, we have to draw a circle or node for each job and activities, then connect the node as per the immediate predecessors and immediate successors, and there must be two nodes for start and finish, so that it will be a unique beginning and end for the project graph. Otherwise, it is not easy to find out from where it is start and where it ends. So, this is essential steps which are required for the activity on node diagram, and by this way you can construct the activity on node diagram. Now, let us see some of the activity on node diagram which are previously shown you in the last class. Now, you can see this is the example which we have discussed, where these dependencies are defined by this defined using these dummy activities which is eliminated here. Okay. So, you can see this is the C D E ends. So, these two start and end are required for terminating these projects, but here these are not required, but here dummy jobs are required, here dummy jobs are not required. So, now let us compare between the activity on node diagram and arrow diagram. So, this comparison is very interesting. You can see arrow AON diagram is simpler and having some advantage during the construction over arrow diagram, and it is easy for the new person also. It is very easy to explain their dependency, it is very easy to understand also, where for arrow diagram because of the dummy job it is little bit difficult, but the problem the benefit arrow diagram is having while we are carrying out computerized analysis for the complete network, especially for the optimization, and we go for frequent changing of the costing and time scheduling part for the critical path method analysis and for the program evaluation review technique analysis, that time arrow diagram is much better, because they represent by a node in an arrow diagram, and that is why it takes for a long computerized system arrow diagram representation needs lesser memory, because that can be explained in a arrow of starting node and ending node, but for the activity on node diagram, the activity will be defined in the computerized system with its predecessors and the successors. So, its array requirement is much higher, that is why the memory requirement will be more for a complex project while we are carrying out for the activity on node diagram in compared to arrow diagram. So, though dummy jobs are there and it is difficult to place those dummy jobs personally when it is carried out, but if it is carried out, then the analysis in a computerized system is easier for the arrow diagram than the AON diagram. Arrow diagram for computer based calculation in part CPM scheduling is superior, because two numbers from job identifications and automatically able to read the immediately predecessors and successors. So, that is easy for the arrow diagram, and AON diagram list each job's immediate predecessor successors, which is difficult. Database or string has to be provided, which is insignificant in the advanced computer, because it is taking much memory for those things. We have already discussed these things. Now, let us discuss few examples. We will discuss two examples from the mining industry, one for the open cast mine, one for the underground mine. Then I will show you one example for the construction industry. Your job is to practice that construction, because that is a very big network. You have to practice that in your house, so that or in your hostel, so that you can understand or check whether you are able to solve that one or not. So, let us consider this one, where drilling of overburden, charging of overburden, drilling in coal, charging in coal, then blasting will be carried out both together, then mucking in coal, mucking in overburden, secondary drilling in overburden is required. Coal we do not expect a larger size boulder, then phase preparation and OB and coal is required, and based on that our expert systems are showing that we have to carry out drilling before charging. So, that is essentially required, that B is having A as the predecessors. We must charge the hole first before blasting. So, B and D is required before we are carrying out the blasting E. Similarly, blasting must be completed prior to marking in F and G, and secondary drilling can be carried out only after marking. That means, when the shovel will sorted out the big boulder, after that only the secondary drilling will be carried out here. So, the secondary drilling of OB will be carried out after the marking in OB, and the face will be prepared for the next blast after those H and F, that means secondary drilling and blasting at OB and marking at for this case marking at coal. So, this is the very simple network and very easy for a mining engineer to understand that how drilling, charging, then blasting has to be carried out, then the marking will be carried out, big boulders will be sorted, then the secondary drilling and blasting, actually this is secondary drilling plus blasting will be carried out in the secondary boulder, big boulders, then the face will be prepared for the overburden and coal for the next round of operation. So, this is very easy to understood. Let us see if we show the network. So, activity on node network will represent like this. Activity on arrow diagram is being represented like this. Actually the durations are not given, you can add the duration at this position. So, these are the first jobs, drilling, then charging, then the blasting will be carried out only after completion of this one. Then this one is for overburden. So, you have to carry out marking, then secondary drilling, blasting, then face preparation, then face preparation. So, this is very easier way to represent this one. If you try to represent this one in terms of activity on node diagram, so it can be represented in activity on node diagram. This is the starting, then the drilling, overburden and coal, charging, overburden and coal, then blasting, then marking, then secondary drilling, blasting, then face preparation, that ends. So, this construction was very easy for both the cases, because we need not to have any dummy job in this case. So, this is another underground requirement, where face drilling is carried out first, then the charging, which is having the drilling requirement, then the blasting, which is having the charging requirement, fume clearance, which is having the blasting requirement, then scaling, only man can enter into the face after the fume is cleared. So, scaling can be done by the human being. So, that is why fume clearance must be essential to carry out the scaling in the roof. Then the light cable will be reinstalled. During the scaling itself, you can carry out the extension of the light electrical cables. So, fume clearance is the precedence of the light cable extension. Then marking will be carried out if it is scaling is already carried out and the sufficient lights are there, then we will allow for the marking. Then after marking, we will provide the support, as you are closing to the unsupported span, your unsupported span is extending. So, that is why you will go for the supporting in terms of roof bolting, etc. Then you can extend along with the supporting system, you can extend the drainage along with the supporting system. So, this job can be done together, and that required the completion of the marking only, because the tub movement and others will be there, or shuttle car movements may be there, or maybe the LHD movements are there. So, that will prevent the operation of these where human manpowers are involved. So, but completion of that one is allowed the manpower engagement in these three activities, and finally, after completion of all this, the supervisor will come, or the foreman will come, or the overman will come to mark the face again for the next round of drilling. So, this is one cycle of operation carried out in a phase of drift, or in a phase of coal mines, or maybe in metalliferous mines, wherever it is used. So, this is one cycle of operation, and if you try to construct a network, it may looks like this. Actually, it is basically wrong one. This will be a direct arrow. So, this is the dependency showing A is A to B, B to C, C to D, then E and F will be carried out together, and G will be carried out only after completion of lighting and scaling. So, lighting and scaling has to be completed prior to start of marking, but after marking simultaneously we can carry out these 3 operations and the face will be marked after the completion of these 3 operations. That is why the dependency of this one is being shown here using these 2 dummy jobs. So, now this is activity on arrow diagram, which is presenting the cyclic operation of one underground mine face. Now, if we see the activity on node diagram of the same, you can see this is the drilling, charging, blasting, fume clearance, then it is scaling and extension of electrical cable, then marking, then the 3 support drainage duct extension operation, then finally the marking of the face, and this is the end of the procedure. So, this is a simple one for the underground, but in activity on arrow, that diagram requires 2 dummy jobs to be defined there for the completion of the network, but which is eliminated in this activity on node diagram. So, let us give you one example for the construction industry as it is available to you now. This is a very long, you can say A to A, B, C, D up to V is there, and those jobs and durations are there, and you have to complete this one by your house. You can say this is your home assignment. I can show you one glance of this one, but do not see this, just only one glance. Okay. I want that you must complete the activity on arrow diagram of this one and activity on node diagram of this one, and if you are able to complete this one by your own, then you can consider yourself are gathering or acquiring the sufficient knowledge for the construction of the network. So, basically this ends this lecture. My expectation is that with this lecture you now think that you are able to construct any network, or you can practice a number of construction of a number of network only from the table given in the different textbooks or available in the internet, etc. by the predecessors jobs or the successors jobs. Do not follow the alternate. If alternate is given, that means already the network is constructed. So, you have to construct the network by getting only the name of the predecessors and the successors of the job. If you carry out n number of examples, if you are able to complete those by your own without seeing the solutions, then you can think that you are now expert for the network construction. Okay, thank you.